Lesson 1, we're on page 781. So you can see right there. Now, in this video, our focus is on independent versus dependent events. And a highlighter comes out. Independent events are events for which the occurrence of one event has no impact on the occurrence of another. Does that make sense? Dependent events are not. So for example, if you have, not a sponsor, a jar and it contains one blue marble and one green marble and two yellow marbles, and you are going to randomly choose a yellow marble out of the jar and then choose a yellow marble again. The thing is, if we're going to put the marble back, that's the key criteria that's missing here that needs to be, make sure we find it. A jar contains, imagine you randomly choose, you replace it. We have to find that word replace, or later on you'll see in the next example we'll say without replacement. Because if I take a marble out and then I put the marble back in, then when I do that, I'm keeping the scenario of all possible outcomes the same. And so the event will not impact the next event. This is the tree diagram. We've been talking about tree diagrams in class, and so the tree diagram outlines the different choices or situations, the different events that are possible, and all of the possible outcomes for that event. Here we have one blue marble, one green marble, two yellow marbles. And now they're meant to be two separate branches because one branch is for that specific marble and the second branch is for the other. But if you're going to replace the object after you take it out of the jar and you put it back in, then BGYY should be the same for what if you drew a blue marble, put it back in the container. Now you're going to draw another BGYY container, marble from the container. Or, and again, this isn't like saying it's all happening all at once. These are paths. These are choices or scenarios that are occurring. So in the next situation, a green marble would be drawn, and if you put it back in the container, maybe the green marble showed up again because you drew it twice. We want to talk about like that as a situation or as an event that could happen, and then how likely is it? How likely is it that you would draw double greens or double blues or etc.? The events of randomly choosing a yellow marble first and randomly choosing a yellow marble second are independent events because the yellow marble was replaced in the jar. With replacement, the object goes back in, and then one scenario to the next. We do not change the probabilities because we're keeping everything from this level to the second level exactly the same. However, again, the key thing is we're looking for the words without replacement or with replacement. Imagine, same scenario, that you randomly choose a yellow marble, and then after you choose that marble, without replacement, you don't put it back into the container. So our number of marbles has changed in the container from 4 to 3. And that is going to therefore mean that this level of the tree diagram, whatever choice, whatever like branch path you're on, totally depended on the first branch that you fell like down. Like you followed B because you drew a blue marble, but now there's no more blue marble in the jar, so you only have a green, yellow, or yellow option. So our idea of independent and dependent events is totally based upon whether or not we change something in the scenario where you no longer have access to the first option that you got, or choosing that first, making the choice for that first item means that was it. That's all you get, and you have nothing else after that point. That's no longer an access. You now have to follow the consequences of your decision. Well, that's it for 781. So far in this activity, we talked about disjoint sets, intersecting sets, union of sets. We talked about independent and dependent events. This is absolutely a dependent scenario because of the word without replacements. It changed how many options there were from first level of 4 options to next level of 3 options. And typically, if the number of options available to you goes down as you do decision after decision after decision, you're in a dependent situation. There's a more formal definition for it. If you want to know more about that, come talk to me outside of class time or whenever you're interested, and we can outline like some ways to mathematically show that we have dependency. Thank you for watching this video. This episode is over. The next episode for us is page 781. So if you would, click forward, keep learning about probability, and we'll see you in the next video. Thanks.